Bismillahirrahmanirrahim. Dear student, let's start with the experiment 3 of the automatic control system part of the electrical testing 3. The experiment 3 is about studying the types of the control system. So this experiment has 3 sub-experiments. The first one is about the P control system. The second one will be about the control system with the time delay of higher order, and the third one will be the control system without the compensation. So let's start with the first part, which is about the P control system. Now, as we know that all the real systems are basically encountered by some time lags here. But sometimes these time delays or time lags are so short or small that it can be ignored or disregarded here. So normally these types of the systems or plants demonstrate the pure action response without time delay and normally are modeled as the P control system. Now, if from the figure as shown in the figure, we said that the step response of the P system is again another step here. Okay, now we can see here, this is the P control system. The input is Y, the output is X. And you can see here, when I give a step signal at the input of the P control system, we get another step signal, which is the response of this P control system. And we can find the value of Kp by dividing the amplitude or the magnitude of the output with the input here. Okay, and this is what we are going to demonstrate today. So the main experiment is basically we are going to investigate the characteristics of the P control system, and this P control system is basically modeled by the light control system in our experiment. Now on the COM3 board we will find a light control system here. You can see here we are going to have a light emitting diode here or LED here basically, which is going to emit some light source here. So it's going to emit some light source. The light will be deflected back by some deflection sheet here. Okay, and this is going to come and it is going to be absorbed by some photo transistor here. So basically the system is modeled as like we are going to give the input at the YL with some voltage here, and the LED is going to send some light signal which is going to be absorbed by the phototransistor, and we can observe the output at the XL here. Okay, now what we will do basically in the experiment, we are going to connect input with the function generator, output is going to be connected directly to the oscilloscope, and also input is connected at the Y1 channel and output is connected at the Y2 channel of the oscilloscope here. We will open the step response plotter from the software, and we are going to make these changes in the step and the duration here. Okay, so once we commence the recording, we are going to get an output like this here. Now we can see here Y1 is basically my input as I show here. This is connected in the Y1 channel here, and Y2 will be the output here. So Y2 is going to be the output, which is shown with the green signal here. Okay, green line here. Now what we find here or what we can observe here, we see that when we give a step signal, which is this blue line here, we immediately get another step signal, which is the response of that input signal here. Okay, when we give the input to the system. So basically there is no time lag here. So this is what we need to observe here in the P control system. Secondly, to calculate the value of Kp, what we will do, we will move the cursor to the output and to the input here. Now at the input we have the green cursor, output is we have the red horizontal cursor, and you can see the output value is 14.93. The input is almost 10 here. Okay, so if you divide the output with the input, we are going to get the value of the Kp. The second experiment is about studying the control system with the time delay of higher order. Okay, so basically what we are going to do, we are going to investigate and determine the time delay, which is basically represented as Tu, and the compensation time, which is represented as Tg, of some PT2 element here. Okay, so let's suppose, for example, this is the response of the system here. So what you will do basically, we are going to draw a tangent which is going to touch this transient state here or transient area here. Okay, so now how we say that which one is Tu and Tg? So Tu is going to be the time span between the injection of a step signal and the point where the tangent intersect with the time axis. So basically when we draw a tangent here, so the tangent is going to touch the time axis and the time from where we give the our step signal here. So basically this duration is going to be your TU here. Then,
your consent on a few items to continue.
So the next step here is basically the compensation time here. In the compensation time, what we have, it is going to start from the place where we finish with the TU, means this point where the tangent touches the time axis, from this point up till the point when it touch your step signal here, okay, which is at x0 here. So this area is going to be your TG. You can say here TG is the time span between the ellipse of the TU and the point where the inflection tangent intersect with the step response here, and step response and values x0 and is measured for the duration of the transient process. So basically this TU is going to tell you the how quickly the response is, like the response speed here, and this TG compensation is going to tell you the duration of the transient process here. So this is what we are going to observe in our experiment. So since we are going to use a PT2 element, so we are going to connect two PT1 elements here together, and we can connect it with the function generator, and the output of the second PT1 element is going to be connected to the Y2 channel, means this is your output, and Y1 is going to be my input here on the oscilloscope. We will again open a step response plotter here, and we are going to change the value from 0 to 10 volt, and we can record it for 5 seconds here. Now we are going to get this response here. So basically what we have here, so basically you can see here, I mean I have a step signal and I have a response of the signal here, okay, the second signal here. Now we have two channels. You can see at Y1, which is blue line here, this is your input step signal. Then the second one is Y2, which is basically the green line, which is basically the response of the system here. Okay, now what we are doing here, we needed to draw the tangent as we discussed earlier. So what we will do, we need to click the tangent here. Okay, so when you click the tangent, you will get a tangent line here. Now first step is what you need to do here, we need to adjust the horizontal area. So we need to bring the horizontal cursor same as your transient area here at this point here. Secondly, the second horizontal cursor which is down, you will need to bring it at the 0 here. So we need to bring two horizontal cursors here. This should be our first step. The next step will be basically we need to bring you can move this one, okay, you can move this cursor and this cursor, vertical cursor now, to bring the tangent such that it is going to touch this transient area here. So for example, it is touching it here. So this is basically this point and the point where I touch this basically step signal. This is basically our TG here, okay, the compensation time here. So basically this area will be your compensation time, which is basically shown as your green and yellow. So since here it is yellow and green, so that's why we are getting a value in the minus. So ignore this one. Say this is 2.65. So our compensation time is going to be 2.65 here. Now for the time delay TU, what we need to do here, basically we need to have the time from the start of the step signal here. So what we did, we basically put another cursor. We have basically three vertical cursor. We put the red cursor here. Now between this red cursor and green cursor, we are going to have the value of the T, which is basically a time delay here. Okay, so in this case, since we can only see yellow and red, so what you can do, you know that this area between red from here up till the yellow is basically 2.83, and the area between green and this one is 2.65. So you can subtract it from this value, so you will get something maybe like, for example, 0.18 or something, whatever. Okay, you can subtract it, so you are going to get basically here the TU, and then this will be the TG. Okay, this was our experiment basically. Now the next experiment is about the control system without the compensation, and we are going to focus on the integral action coefficient, integral action system here. Okay, so the integral system here. Now what we have in the integral system here, basically we can see here like it's a simple system. As we give a step signal, which is basically constant here, the output or the response is going to increase linearly like this. Okay, so you can see like the simplest system without compensation is the integral action or I element, whose output shows a linear rate of rise although the input variable is constant. Okay, the simple example is this water tank here. So you can see as I give the water Q, okay, like the constant value, I'm giving the constant water inside the tank here, the height, which is the output, the height of the water is increasing linearly as I put the water here. So this basically demonstrates an integral element or I element here basically. Okay, so secondly, what we are interested, basically we are interested in finding the value of the Ki, which is basically the integral action coefficient Ki, and we are also interested in finding the integration time, which is basically the reciprocal of the Ki. So if I find Ki, we can take a reciprocal to find the Ti here. Or what we will be doing, basically we will find the Ti and then we will take the reciprocal of this value to find the Ki here. Okay, so what we have basically, when we give a step signal, we are going to get some linear response like this. We can find the value of Ti by this value here. Okay, so on the board you are going to find an integral element like this. So we can give the input here, which will be recorded in the oscilloscope Y1 channel, and the output, which is recorded in the Y2 element here. Okay, and we are going to open a step response. We will change the value of the step 6 change like this, and we are going to record it for the 5 seconds here. So what we have, you can see this is your input, which is the step signal, which is the yellow, the blue one here basically, and we are going to get a response, which is the green one, and it is like this. So how to find the value of Ti here? It's simple. What we will do, the place from where we start our step signal. So we can put one cursor here, like I put here the red cursor here, and the second cursor we put it at the point where these two intersect, like the step signal intersect with the output response here, which is the linear line here at this point. So basically the duration between these two, which is 1.12, is basically your Ti here. Okay, so we can find a Ti here. So Ki will be equal to 1 divided by Ti, and you can find the we can find basically the integral action coefficient here. Okay, so this was all about today's experiment. Thank you.